Okay, so here we have a series circuit, 16.5 volt battery, 12.5 volt battery, a bulb for a load, another bulb for a load, and a third bulb for a load. This bulb is pulled. The batteries are series aiding. Negative, positive, positive connected to negative, positive connected to the load. What is the total voltage? 2911. What is the voltage of this battery? 1252. What is the voltage of this battery? 1659. Say 16.6. 16.6. 12.5. 2911. Works out. Use your calculator if you must. I can measure these separately. That one's separate. This one's separate. Is it on? There's no flow. If I go here, I got nothing. Go here, I got nothing. So, install the bulb. I got a bulb glowing. I got a bright bulb. What do we have across the batteries? This is loaded now. 2886. 2887. How much is dropping across this one? Yeah, 21, about 21.5 volts. How much across this one? 7.09. How much across this one? 0.22. This is about a quarter volt. This one has the least resistance. This one has the most resistance. It's obvious. We got 21, 7, and a quarter. We got 28, 29, whatever. This is a series circuit. Open any part, shuts off. Open any part, shuts off. Open any part, shuts off. Huh. Is there a different current? Is there a different current here, 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 or here? No. It's a series circuit. Same current. Same current. Same current. Negative to positive, positive to negative, doesn't matter. Same current. Same current here, same current here, same current here, here. So previously that was series aiding. I moved these two, so now we have series opposing. The negatives are together, positives are on the load. Can I still measure them separately? Well, they're loaded. Look, we got a glow. So let's unload it. Pull one item, whole thing stops. Boom. Oh, I still got 12.49. Can I measure this one separately? I don't know. Oh, 16.5. Look. Series circuit. I can measure the battery separately. Imagine that. 12.5. 16.5. What's my total? Uh, 4 volts. 4.09 volts. I can measure it. Maybe that's the difference between 16.5 and 12.5. Imagine that. So, now we're connected. We got a glowing bulb. Not very useful though. Let's see what we got. 2.9 volts dropped across this bulb. Remember we got 4, right? Yep. So, how much across this bulb? Yeah, just under 3. How much across this bulb? Just under 1. Huh, not much here. 0.05. So, this bulb is basically acting as a wire. Do you think there's the same current in all parts of the circuit? Is there the same current here, as here, as here, as here, as here, as here? Yes. Same current in all parts of the circuit. Which one is limiting? This guy. Both cases. Series opposing, series aiding. I can measure the batteries. They either add or subtract. This one is the limiting factor. Remember, it dropped 21 volts in series aiding. Now it's dropping 3 volts in series opposing. This is a series circuit. Resistance inside the battery. The other resistance is inside this battery. Nothing else is needed. This is a series circuit. Negative to positive, positive to negative, I don't care. Look at it how you will. We already measured it, all parts of it. All parts of it measured. Thank you. Now I have the two batteries hooked in parallel. Black to black, red to red, positive to positive, negative to negative. Series circuit from here. So what's my total voltage? I'm getting 1635. Remember, 12.5, 16.5. Can't read this one anymore. We know it's 12.5. Can you read it? No. It's in parallel. 16 volts. How much am I dropping here? 12 volts. How much here? 4, a little over 4. How much here? 0.15. What's my total? 1630. Do you think these three add up to those two? Of course they do. Can I read this one directly? No. What if I check out the battery? 1630. What if I check down here? 1632. This isn't 12 volts anymore. 16 volts. This one's 16 volts. These are parallel circuit. This one's controlling. It's charging this. It's powering the circuit. Parallel. Very simple.